Okay, so what we have done so far is we've looked at one geometric reason so far, which I'm going to recap for us in a second on the side here. If my screen wants to cooperate, it doesn't, so that's fine. We've learned one geometric reason so far. So the reason that we learned on Monday, and again, guys, if you've done this at school, yes, you know more, but we're going to go with what we have learned together. We have learned that adjacent angles, so angles next to each other, around a point, add up to 360 degrees. So that's the reason we had to look at on Monday. And remember, whenever you make a statement, you have to give a reason. Our reason for this is literally just angles around a point. We can abbreviate point to PT. That sideways LS means angles. Mathematicians, remember, are quite lazy. We like to abbreviate and shorten things where we can. And so that would be our reason there in blue. So what I want you guys to try for me, and you guys were doing really well with this on Monday, which is why I'm sort of letting you out into the wild here. I want you to try these two questions for me. I'll add numbers to them. So question 1 and question 2. In both cases, you are determining the value of X. So that would be your instructions. I want you to give those two a go. Again, I'm asking you to do this by yourself because we have actually done angles around a point, and so you should be able to apply it. If you can't, give it a try, or if you don't remember, at least try. I'm going to give you, I can't see the time on my computer. I'm going to give you 4 or 5 minutes to do both of them. Answers on the chat with a reason, please. And please remember to number your answers. And then we will go through them. Erin, yeah, it's absolutely fine to you. Your English. It is absolutely fine to use angles in a revolution. That's another reason that we can use for this one. And guys, on that, sometimes at school or your teachers teach you a slightly different reason. As long as you are using a reason that your teachers taught you or that I've taught you and you're not just making one up, that's absolutely fine. Remember, guys, we did speak about this on Monday. This square in question 1, it's a symbol that means 90 degrees. So you do actually know the size of that angle. We don't have to put the degrees there. That little square gives us that information. Excuse me. And remember, grade 8s, if you want to check whether or not you've done it correctly, substitute it back into your original statement or into like the picture and make sure that it does agree with the reason that you've used. If you've used angles around a point, make sure that you do get 360 degrees. Also remember, guys, if you want, you can set up your page in 2 halves, 1 half for your statement, 1 half for your reason. I can't draw a straight line, so that's all right. Because remember, like we said on Monday, you have to have a statement and a reason to go with that statement. I'll give you another minute, although it looks like we've only done question 1, so I might need to give you another 2 or so. Okay, guys, I'm going to give you 1 more minute and then we're going to go through these two. And remember, it's just like solving an equation. We've done a whole equations course. Think back to how we solve equations with inverse operations. That's all you're doing here. That's it. Okay, guys, let's have a look, because obviously we want to learn some fun, new, exciting reasons. If we have a look at our first question, I'm just going to make it a bit bigger. I'll make it smaller just now for you guys to take screenshots. If we look at our first question, what we see is that we have 90, we have 150, and we've got 5x. And so if we add all three of them together, we do get essentially a revolution. So we can make the statement that 5x plus 90 plus 150 must be 360 degrees. My reason, angles around a point, or as we spoke about earlier, I think was angles in a revolution. That's absolutely fine. Okay, now this is an equation that we solve. Now guys, 90 and 150 are like terms. So if we add them together, it's just going to make our life easier. I've got less terms that I need to deal with. 90 plus 150 is then 240, panic there, is equal to 360. And now we start applying our inverse operations. So I'm going to subtract 240 on both sides of my equation. And so I get 5x is equal to 120 degrees. Now, guys, very importantly, remember, I told you that the instruction to this question would be determine the value of x. Right now, I've got 5x. I don't want 5x, I just want x. Again, using this idea of solving equations and inverse operations, I need to divide both sides by 5 because that will essentially allow me to solve for x. And it's really important that we do that because I didn't ask you to solve for 5x, I asked you to solve for x. So we're going to divide 120 by 5, and that tells me that x is equal to 24 degrees. So again, really, really importantly, we need to remember that we're solving for x. The instruction said, determine the value of x, not of 5x, not of anything else, of x and x alone. So we are essentially solving for x. All right, so that was the first one. Again, I'll come back to this so that you can take screenshots. You should also just be correcting at this point, but I'll come back for screenshots in a second. All right, guys, again, what we see here is that we've got a bunch of angles around the central point. So if I add x minus 75 plus x plus 45, once again, I get a revolution. I get 360 degrees. So I know that the sum of all of those angles must give me 360. So x minus 75 plus x plus 45 plus x must give me 360 degrees. So all I did was I added the 3 angles that I was given because I knew that they must give me 360 degrees. My reason, angles around a point, or like I say, as long as your teacher has given you an appropriate other reason, I really don't mind. Okay, now guys, again, neaten up the left-hand side by looking for your like terms. So I can see that I've got x plus x plus x, those are all like terms. I also have got minus 75 plus 45. Again, like terms. Neaten it up, it makes your life easier. X plus x plus x is 3x, and negative 75 plus 45 is then negative 30 degrees. And that is all equal to 360. Now we solve our equation. That's it. We're going to add 30 on both sides. So 3x is equal to 390. We then divide both sides by 3 because that's what my inverse operations tell me to do. And so we get that x is equal to 130 degrees. Okay, now guys, really, look, my cat's got ants in his pants tonight. Really, really importantly, once you solve for x, all x's in your diagram, you have the value for. So this x by itself is 130. This x would be 130 plus 45. And this x would be 130 minus 75. Because they are all x's, they all are exactly the same value. And so once you've solved for x once, you know the value of all x's in your diagram. And that's really important to remember. Right, so I'm going to make that a touch smaller in case you need to take a screenshot. Aren't we supposed to put brackets? So Ortele, you can put brackets if you want around the x minus 75 and the x plus 45. The reason I chose not to is just because I was adding. There was no distribution of a negative, but you can. Absolutely, it's actually probably better to put brackets in, but you don't have to, but you can. So guys, the brackets, it's sort of to like indicate which angles are which. So those would be the brackets that we put in. You're more than welcome to, no problem at all. Zandile, that means angles. Remember, it's like the symbol angles. Canva, what order of operations? Canva, I'm not really sure I understand your question. So if you'd like to raise your hand to try and ask me to help me understand, that would be great. If anyone else has questions they want to raise their hands to ask, you're welcome to. Otherwise, we're going to start with our new reasons today. Canva?
Hi, ma'am.
Hi.
How are you?
I'm right. How are you?
I'm fine, thank you. I was going to ask, like, in what order of operations did you like add? Did you add the like to do the inverse operations, ma'am? Like, or did you use BODMAS or something?
Okay. So yes and no. It sounds like a weird one. So basically, when we solve an equation, what I always do is I identify where my x is. So x is here. No, let's maybe do that a bit better. X is here. What is attached to x is a subtraction of 30 and then a times 3, that coefficient. And so when we solve equations, we almost do BODMAS backwards. The first thing that I deal with is actually this minus 30. It is this thing that I can deal with very quickly by just adding 30 on both sides. And so I start with that. Once I've dealt with that additional subtraction, I then see that I have this coefficient. And that is the division and the multiplication is what I'll deal with last. I hope that answers your question.
I understand, ma'am. Thank you.
Perfect. Cool. So yeah, like I almost think of it as if you think of like a flow diagram that we can use to represent an equation. When we go forwards, we follow those order of operations to a T. But solving an equation is to go back to what x originally was. So we almost have to work backwards in order to get there. Yes, you get marks for reasons. Remember, very, very important, guys. Right, Joshua?
Okay, man, where did you get the 3x from?
Okay, so remember the 3x came from me adding my like term. So if I go back here, I've got x plus x plus x. So because I'm adding 3 x's, I end up with 3x. Make sense?
Okay. Yes, ma'am.
Cool. Zandile, sorry, I've made it smaller now. You should be able to take a screenshot. Cameron, we will eventually get there. Yes. I'm hoping I haven't missed anything. Sibongi? Hello?
Hello?
There we go. Have you got a question?
Okay. Yes, I got a question. How does the 3x came from?
Okay, so just guys, please try and listen to each other's questions and listen to my answers. So I have just explained this, but very quickly. X plus X plus X gives me 3X. So it's just adding my like terms.
Oh, okay. I
Okay.
get it.
Cool, well done. All right, guys. So I hope what you're also trying, oh no, okay. All the English words just went. I hope what you're seeing is that we are mixing a lot of algebra into geometry, all right? What we need to get used to is the fact that sections in maths aren't separate. A lot of them overlap, a lot of them have to do with each other. We are mixing geometry, algebra, equations, all of these things into one section. And so that's why it's so important that we don't just say, oh, well, I can't do equations, so I'll just leave it. Equations comes in pretty much everywhere. We have to be comfortable with it. All right, so I hope you've all got your screenshots here. I am moving on to our next set of reasons. I don't know if you saw, but today we're going to do 2 reasons, mostly because the second reason, complementary angles, is honestly a reason we don't use a lot, but it is one that's useful and important to know. We'll focus a little heavier on the angles on a straight line, but complementary angles is still important to know. All right, guys, so the first reason that we're going to have a look at today, as I've said now multiple times, is angles on a straight line. Just need to shout at my cat, hang on. It's like having a child. Anyways, angles on a straight line. Now, guys, the heading is sort of explanatory to what we're going to do. If we look at our diagram over here, what we see is that we've got multiple straight lines, but very importantly, we've got this bottom straight line on which 2 adjacent angles sit. So I've got the angle ACD that I'm going to mark in orange there. And I've got the angle DCB, which I'm going to mark in green, right? Now, what this reason says to us is that if we've got adjacent angles on a straight line, now remember, adjacent means next to, they will add up to 180 degrees. Okay, now, yes, you're welcome to use supplementary angles. That's not a problem. Supplementary in maths and geometry needs add up to 180. So that's no problem. I use angles on a straight line. But again, guys, as I have said multiple times, sometimes you have learned different reasons to what I use. As long as your teacher has told you it's a reason you can use, I'm fine with it. I use angles on a straight line. You can use whichever reason you've been taught. I don't mind. So this angle says to me that as long as we have adjacent angles, so angles next to each other, basically they share a common vertex. As long as they are adjacent, when we add them together, they must give us 180. All right, now this makes sense, right? If we have a circle, basically angles around a point, and we cut that circle in half, apparently I can't draw a straight line again, half of a circle consists of 180 degrees. There is my straight line. All right, so it makes sense that if I'm cutting a circle in half, I'm only working with half the number of degrees. Now, again, anytime in geometry that we make a statement, we have to give a reason. It is a non-negotiable fact of life. Your reason that you are going to use, remember, I always put them in the block. The reason that we use is angles on a straight line. Or if you're going to use supplementary angles, that's absolutely fine as well. I use angles on a straight line. That is the reason I am going to use. But for like the 7 millionth time, if you have learned another reason, if your teacher has given you another reason, I am fine with you using the other reason. Okay, so that's the first reason we're going to look at. The second one that we're going to have a look at, like I say, is complementary angles. Not one that comes up a lot, but is one that we need to know. Right, so in maths, complementary basically means adds up to 90. So complementary angles is when we have, once again, adjacent angles, so angles next to each other, that add up to 90 degrees. All right, so if we go to our diagram, what we can see here is that we've got an angle of 50 degrees and an angle of 40 degrees. If we added those two together, we get 90. They are adjacent angles. They have a common vertex. They're next to each other. And so what we could actually do here is we could use that square in order to represent that we have a right angle or a 90-degree angle. So complementary angles, guys, are angles that add up to 90 degrees. The reason that we use, if we are going to use the statement, or if we're going to use this reason, is comp angles, complementary angles. So again, not one that comes up a lot, but one that is important to know. And more specifically, the word complementary. It's useful to know that when I talk about complementary angles, I'm talking about angles that add up to 90. So I'm going to give you a second to take a screenshot. And then we're going to have a look at some examples of applying these reasons. Right, I hope we all have our screenshots. The first one is very easy and you guys will probably get this very quickly, but I'm going to go through it with you. I'll give you some to try it by yourself. We're just going to go through the first one together so we're all on the same page. Alrighty, so here's our first example. Remember, whenever we set up our answers, we are going to split our page in half so that we remember to write down both a statement and a reason. We don't want to be making silly mistakes like forgetting to do one or the other. Canva, must we write the word as is or in full? Okay, so Canva, you can write comp. That's absolutely fine. In maths, abbreviating is fine. So if you write complementary, you won't be marked down, but writing comp angles is perfectly fine. Okay. So guys, we've got a statement, we've got a reason. Now, like I said, as we start to learn more and more reasons, we need to start training our eye to look out for certain things in a diagram. Is there a central point around which we have angles? How many straight lines do we have? Do these straight lines have a relationship with each other that form maybe a cross shape or a Z shape or whatever? All of these things we're going to look at. So if I look at my first diagram here, what I see is that I have got two straight lines, but importantly, this bottom straight line is the line I'm concerned with. The reason for that is because I see I've got a common vertex to both the angle X and the angle 50. So because there's a common vertex here, that's telling me, and because we've got a straight line, that's telling me that I'm probably going to use angles on a straight line or supplementary angles. So we're going to make our statement. Our statement is that if we add 50 and X, we must get 180 degrees. So we start setting up our equation. X plus 50 gives us 180. My reason, angles on a straight line. So Canva, again, in response to your question, you don't have to write straight. You can just abbreviate STR. You also don't have to write angles. You can use the slanted L with an S. Right, so guys, inverse operations, we're going to subtract 50 on both sides. And so we get that X is equal to 130 degrees. Now, guys, remember, you can double check yourself. If I now take that answer of 130 and I replace X with it, if I say 50 plus 130, do I get 180? Yes, I do. So I have correctly found my value of X. Please always remember, because what you are in essence doing is solving an equation, you can double check you have done it correctly. Right, so what I want you guys to try and do is try and answer question 2 for me. I want both answer and reason on the chat, please. Remember those inverse operations. Remember your reason. I'm going to give you like another 30 seconds or so, and then we'll go through it. All right, grade 8, let's have a look here. Okay, so once again, what we can see is that we've got adjacent angles. 60x and 80 are all adjacent to each other. And so what that means is if we add them all together, we must get 180. Whoopsie, so sorry. 180 because they're all angles on a straight line. And so we are going to use that exact reason. Sorry, guys, no idea what I did there. Anyways, so we set up our equation. X plus 60 plus 80 must give me 180 degrees. Remember your reason, angles on a straight line. So this is an equation. We're going to solve for x. Now, guys, remember 60 and 80 are like terms. So make your life easy. Just add them together to start off with and then start solving. 60 plus 80 is 140. And then that is equal to 180. Now we use our inverse operations and we subtract 140 on both sides. 180 minus 140 is then 40 degrees. And so I saw most of you had put on the chat there that x in this question was 40 degrees. All right, so excuse me. Remember that as long as you've got adjacent angles, so angles from a common vertex that are on a straight line, my straight line being this one at the top here. Yeah. When you add them all together, you get 180 degrees. Alrighty, so take your screenshots of those two just in case you didn't. I don't think there's any questions. However, if there are any questions, please raise your hand to ask me. Otherwise, I'm going to give you another one to give a try of now. So if you have a question, please feel free to raise your hand. Otherwise, take your screenshots and then we're going to move on. Good, grade 8, nice. Alrighty. So I want you to try question 3 for me. By yourselves, try question 3. Remember the instruction, solve for x or determine the value of x. That is what we want to do here. Remember, like I said earlier, once you've solved for one x, you know all of the x's in the diagram. So once you found x1s, you don't have to do it again just because there's 2. So think about what you have, think about what reason you can use, and let's see what you get. Answers in the chat along with the reason, please. Right, remember everything you know about algebra and solving equations? Like I say, once you get down to it, geometry is basically solving equations for unknown angles. That's really all we're doing in geometry. Okay, so I've got a question of, is the angle always going to be 180 degrees? It will only be 180 degrees if you're working on a straight line. If not, then no, the angle will be something different. But the reason we have here is angles on a straight line, however that straight line goes. And if you've got angles on a straight line, they will always add up to 180. I'm going to give you another minute. And then we'll have a look.
You guys are doing well. You're doing awesomely. Nice to see you getting this stuff.
Okay, guys. So remember statement reason. Now, what we see here, and this is what I was saying now, is we've got a straight line on which we have adjacent angles that come from this common point. And because of that, we essentially have this half circle shape. So we've got 180 degrees. Okay, so our statement is that x plus 60 must give us 180 degrees. Now you don't have to use the brackets. You can if you want. I'm just using brackets to show that it is my second angle that I'm adding, but you don't have to. I reason angles on a straight line. Alrighty, now we're going to solve our equation. Now guys, do remember that technically there is a 1 in front of this bracket that I would have to distribute into the bracket. But remember, timesing anything by +1 doesn't change it. All right, and that's why I said the brackets aren't necessary. All you have here is x plus 60. That's it. X and x are like terms, so x plus x gives me 2x plus 60. I'm going to use my inverse operations and subtract 60 on both sides. And so that's going to leave me with 2x is equal to 120 degrees. Now remember, you are determining the value for x. So what we now want to do is we want to divide both sides by 2, because I don't want the value of 2x, I want the value of x. And so x is equal to 60. Now guys, remember what you can do is you can substitute back in. So if I go to my diagram, this x is 60 and this x is 60. Remember, they're the same variable, so they're the same value. 60 plus 60 plus 60, which is actually 120, does give me 180 degrees. It gives me the angles on a straight line that I was looking for. All right, so please remember that once you have the variable, doesn't matter if the variable is repeated, you have that value and it's not going to change as long as the variable is the same. Okay, so take your screenshots of those two just in case you haven't. If anyone has any questions, now's the time to raise your hand and ask. Joshua?
Okay, ma'am, the last question. We didn't time, we only minus 180 degrees by 140 degrees and we got 40. But why in this question did we times?
When you say times, where do you mean we're timesing? What have I times?
Algebra.
Ma'am, the question. When you said the question.
Divide.
So remember, I'm not timesing anywhere, but I am dividing. So because I've got two x's here, the coefficient of x becomes 2. And because I want to solve just for x, I have to divide the 2 away. Does that make more sense?
Oh,
Yeah?
yes, ma'am.
Okay, perfect. All right, Cameron?
Hello, ma'am. How are you?
Hi, I'm good. How are you?
I'm good. I wanted to ask a question about this. For every angle that we do, is there a total? Like, for example, angles on a straight line has like 180. Like your equation will equal to 180.
So, yes and no. Every angle that we do will have some sort of relationship. It will either be equal to a certain value, or it will be equal to another angle that has the same value as it. So when we start looking at parallel lines, we're going to see that there's certain angles that are equal to each other, and we can also use that in an equation. So some of them have a
Alright.
certain value, some of them are just equal to each other.
Okay, thank you.
Pleasure. Zandile?
Afternoon, Jeffro.
Hi, how are you?
I'm good, and how are you?
I'm good, thank you.
So, Jeffro, my question is, in equations and in angles, is there an invisible one in X alone?
Yes, good point. So guys, remember, in front of any variable by itself, there is that invisible 1, which is why when we added them together, 1 plus 1 is 2.
Okay, thank you, Jeffro. I was wondering where the 2 comes from.
Yes, sorry, thank you. That's a really good point. So guys, exactly like Zandile's pointed out, in front of that variable x, there is that imaginary, no, let's not say imaginary, invisible 1. And so exactly as Zandile said, that's where the 2 has come from. Good, well done.
Nice, guys.
Lubanzi, yeah, I'd probably give you that. Try and set it up as an equation and solve for an equation. It seems really silly, but it is sort of how we need to start getting to that point. But you're doing the correct operations and the correct maths there. So that's okay. Okay, guys. So we've looked at a few angles in angles on a straight line. What we're going to have a look at very quickly is complementary angles. So Jason, we usually do brain breaks, but we are motoring today because we need to obviously get through our stuff. What we're going to do is I'm going to do this question, and then I'm going to give us like 2 minutes to just have a stretch, have a break, and then we'll have a look at 1 or 2 more. All right, so guys, this question, the reason I'm saying complementary angles is very clearly because I've got this square here. So what I'm saying is that the whole sum of these 2 angles must give me 90 degrees. So again, we don't use complementary angles a lot. It's not one that comes up a lot, but it is important to be aware of. So we're going to do an example so that we know how to deal with it. Right, so again, remember, complementary angles means that we have adjacent angles that add up to 90 degrees. We can make the statement that x plus 70 must give me 90 because they are comp angles. Remember, we can abbreviate complementary to comp and the sideways LS to angles. And then we use our inverse operations, subtract 70 on both sides, and x is equal to 20 degrees. And that's really all complementary angles is. Yes, obviously I could do something like the previous question, question 3, where I introduce more than one variable, but because we know how to solve an equation and because we've done it with angles on a straight line, it doesn't change all of a sudden when I get to comp angles. It's now equal to 90, not 180, but your method is exactly the same. All right, so comp angles is when it adds up to 90 degrees. And like I say, it doesn't come up a lot, but it can come up, and it is important to know how to deal with it. All right, so guys, you've got 3 and 4 there on your screen, just in case you haven't taken screenshots. Have a stretch, touch your toes, and then we'll have a look at another few examples in 2 minutes. So just yeah, take a little break and then we'll carry on in 2 minutes. Ooh, excuse me. Clearly me too, Tito.
Yeah, just stretch, guys. Oof, I also feel my bones.
I had to get up so early this morning because apparently I'm a good partner and take my boyfriend to the airport. But I had to wake up at 4:30. 4:30. I got to school and they were still unlocking the school. And then I forgot there was load shedding from like 6:30 to 8. So I was like happily working away
No.
at my computer, and then the power went off. And obviously at that time in the morning, it is pitch dark. So I was just
Yeah.
sitting in my classroom by myself, and I was like, okay, that's fine.
Zandile, you can't take a screenshot. Take a screenshot, please.
Okay, someone can't see the screen. Remember, you need to try what Yolanda said of unpinning my like block and seeing if it works. If you're still having a problem, let us know, and then I can reshare my screen.
And Joshua, stop looking at them. You're supposed to look at the screen.
Yeah. Right, guys, I hope we've all had a stretch. We're gonna, my sweet child, just sit here, okay? Sit here nice. Joshua, do you have a question before we carry on?
Okay. Ma'am, I'd just like to say thank you.
Absolute pleasure.
Ma'am, I'm Joshua's twin sister, so my name is Princess.
Princess, it's so nice to meet you. I'm so glad you're joining us as well.
Okay,
I
thank
see
you, ma'am.
every lesson, and I'm very glad it's helping.
That's so cute.
Alrighty, sweet, sweet children. Thank you, Labanzi. They are being so naughty at the moment, but I do love them. All right, my wonderful children. Right, I'm going to skip 5. I want you to try 6 for me. We'll come back to 5 in a second. I want you to have a go at question 6. So give it a try. Answers in the chat. Reason with your answer. We are nearly there. So you can do it. You've got it in you. Question 6. Now, obviously, there's an m variable there, but basically you're solving for m, right? Just because there's a different letter there doesn't mean anything changes. We're just solving for m now. Figure out, please, my girl. Total 200. I'm gonna assume that was probably a mistake. Guys, remember those reasons, please. It's all right, Tato. It's a Wednesday. Good. I'm liking that our reasons are coming through as well, guys. Well done. You're doing really, really nicely. Remember, set up your page so that you remember to do your statement and your reason. Good, guys. And guys, it's okay. So a lot of you are saying, oh, I keep thinking we're still doing angles around a point or 360 degrees. That happens, all right? What you need to remember is that this is sort of like the first year in high school that you're doing geometry, but also the first time that we're starting to really like add complexity to geometry and that we're starting to form this foundation. It's fine if you get a little bit confused at the start. That's okay. As we start to go on and as you start to learn more and more reasons, it's going to be important that you can differentiate. All right, but remember, you are committed students doing maths at 8 minutes to 7 on a Wednesday evening. That's okay. A mistake will happen, and this is where we make mistakes. This is the place to make those mistakes. Settle, don't worry. When we do it, it will be fun. No frustration. Okay, lovely, lovely children. Let's have a look here. So what we see is that we've got PQR, which is a straight line. And yes, QS and TQ are straight lines as well. But the reason I'm specifically picking PQR or PR is because I see that there's that common vertex there, around which I have 70, 80, and M plus 10. I have 180 degrees, which means that I can now set up my equation. I know that M plus 10 plus 80 plus 70 must give me 180 degrees. Obviously, I don't leave myself enough space. No. Fine. My reason, angles on a straight line. Right, now that we have that, we can go and solve. Now remember, 10, 80, and 70 are all like terms. So I've got M plus 160. Must give us 180. We're going to use our inverse operations. I hope I can do math. Yeah, I can. We use our inverse operations and we subtract 160 on both sides. So M is equal to 20 degrees. And I think most of you on the chat said that. If you didn't, you probably made a silly little mistake. So again, this is where we make the mistakes. This is where we do the silly things so that we can correct ourselves. Oh, excuse me. All right, guys, I hope you've taken screenshots. If you haven't, quickly take one, and then we're going to go back up to 5. I am going to get you to try 5, but I am just going to explain 1 or 2 things before I just let you go, or let you try it rather. Screenshots of 6. Right, let's have a look. So what I'll do is I'll just leave it up like that in case you haven't taken the screenshots. So guys, question 5 is not hard. What is different here though is the fact that you've got 2 variables. Now this is what you have to get used to in the good old geometry. As we move on with our geometry, what you're going to see is that you're often going to have diagrams where you've got multiple variables and you have to solve for all of them. So here I've got the angle X as well as the angle Y. 2 different angles. I know that they're different because one is X, one is Y. They've got different variables representing them. And so that means they are different in size. Okay, that's the first thing. Second thing is, the second we start having more than one variable that we need to solve for, what we need to remember is we do each one separately. So I'm going to solve for X, get my answer, solve for Y, get my answer. Because they're 2 separate variables or 2 separate angles, please remember that for each new working out or each new angle or idea, you have to give a reason. So you're going to give a reason for X's statement and a reason for Y's statement. Now, guys, what you will see is that depending on where you start, there are 2 ways to get the last or the second angle. And I'll explain that when we go through it. Okay, but what I want you to try and do for me is I want you to try and work out the values of X and Y. I'm going to give you 2 minutes, 3 minutes. You shouldn't need that long. Everything is there that you need. And then we'll go through the answers in like 2 or so minutes. So exactly, guys, answers and reasons on the chat, please. I'll give you another minute just because I still want time to go through it. Remember your reasons, please, guys. Right, let's have a look. If you're not finished, that's okay. You can just fill it in as we go along. The first thing I do want to say, grade 8s, is unless we specifically tell you that you have to do it in alphabetical order, it makes no difference whether you start with X or Y. As long as you give me answers for both, I'm happy. Most of us generally just start with X anyways, and that's fine. But I just want to point out it doesn't matter. So if we start with X, what we see is that X is an adjacent angle to 140, and it is on the straight line there that I've drawn in blue. So we can say X plus 140 gives us 180 degrees, and our reason angles on a straight line. We then solve the equation and we get that X is equal to 40 degrees because I would subtract 140 on both sides. Okay, so nothing too tricky. Now, guys, the second I have diagrams where I've got lots or multiple things that I need to solve for, I actually fill in the angles as I go along because me knowing X might help me find Y. Now, this is why I was saying there's 2 ways you could find Y. The first way that you could find Y is because you have 140, 40, and 50, you actually have angles around a point. So if you wanted to use angles around a point equal 360 degrees, no problem there whatsoever. Okay, because this lesson is about angles on a straight line, what we see is that Y and 50 degrees are also adjacent angles on a straight line. And so Y plus 50 must give me 180 degrees. Now, guys, remember I said this is a new angle, so we need to give a reason to it as well. Angles on a straight line. Or if you're using 140 plus 40 plus 50 plus Y equals 360, your reason would be angles around a point. Both are absolutely fine. You will get 4 marks. Inverse operations, subtract 50 on both sides, and Y is equal to 130 degrees. So guys, when you get multiple variables, it is not something to stress about. You solve it exactly as normal. The only thing you need to remember is that for each new angle, you must give a reason.